In this video, you will learn how to algebraically solve quadratic systems. In the previous lesson, we learned how to solve quadratic systems by graphing, but as you probably realized, it's pretty time-consuming. Plus, if you get fractions or any sort of decimal, it's very difficult to estimate where the two graphs intersect. So it is better to typically solve algebraically. So when you're solving, there are two different methods that we might need to use. The first is if our equations have unlike terms, we want to use a substitution method. And then if they have like terms, we want to use the linear combination method. And we're going to take a look at both of those scenarios here in the following moments. So looking at the unlike terms, we have example 1, where we have 2x squared plus y squared equals 6, and then 3x plus y equals 1. All right, so this first graph up here, this first equation would be an ellipse, and then the second equation is a line. Now notice that these are not like terms. Like we have, looking here in these columns, we have x squared and x. Those are not the same terms. Here we have y squared and y. Those are not like terms either. So what we can do is we can use our substitution method. What that looks like is, notice the second equation here is linear. All right, because it's linear, it's going to be much easier to do that method of substitution, where we solve for either x or y. All right, and notice that y is going to be simpler to solve for because all we need to do is bring over the 3x to the right side. So the first equation would stay the same, and that should have been a 6 right here. And the second equation, when you solve by subtracting 3x over, we now have y equals 1 minus 3x. So we chose to solve for y for that second equation. Now once we have solved for one of the variables, what we can do is we can substitute. So we substitute back into the first equation right here. So we solve for y, so in place of y, here in this equation, we're going to plug in the 1 minus 3x. So now we have 2x squared plus, and then 1 minus 3x, that whole thing is going to be squared, and that's equal to 6. And then from here we can just solve for x. All right, so when you have 1 minus 3x squared, remember that is 1 minus 3x times 1 minus 3x. So we distribute the 1 to both terms. We have 1 minus 3x. And then we distribute the negative 3x to both terms. Negative 3x times 1 is negative 3x. And negative 3x times negative 3x is going to be a positive 9x squared. And that's what we see up here typed up. So we have the 2x squared in the front plus the 1 minus 6x and then plus 9x squared. And right, this can combine to get negative 6x. All right, so from here we can combine. So 2x squared plus 9x squared would be 11x squared. So it's 11x squared. And then we have the minus 6x. And then we have the plus 1 equals 6. And the 6 we can bring over here by subtracting. So now we have 11x squared minus 6x minus 5 equals 0. And we see that typed up right here. So from this point, we have a quadratic equation that we can solve. So we can use either factoring, we can use completing the square, or we can use a quadratic formula. This one actually factors pretty nicely. So we're assuming at this point you know how to factor. All right, so we want 2 terms here and 2 terms here. And we want the first terms to multiply to get 11x squared. And that's going to be 11x and then 1x. Because when you multiply, you get 11x squared. And then for the last numbers, we want 2 numbers that multiply to get negative 5. All right, so we're going to have to experiment for this one. So it could be either 5 or 1, and it could be positive, positive or negative. Right, so for example, if we put the 5 here and the 1 here and make the 5 positive, the 1 negative, 5 times negative 1 would be negative 5. And if you check the inner and the outer terms, we get 5x and then negative 11x. That's going to give you negative 6x, which is the middle term. So you think through reverse distributing or reverse foiling, and that's going to be how you factor. So that factors, and we get that right there. Now from here, once we have factored, we can set each part equal to 0 because we have two numbers multiplied together equaling 0. So either 11x plus 5 is 0 or x minus 1 is 0. So the first one we can solve by subtracting 5. We get 11x equals negative 5. Then divide by 11. That gives you x equals negative 5 over 11. And then for the second one, just add 1. So we have x equals positive 1. And we see that typed up right here. All right, so we have two different answers. We have one where x is negative 5 over 11, and the other when x is equal to 1. Now remember that these graphs will intersect at a point. So we have the x components. We just need to plug back in at the end to find y. So it's going to be best to use this equation right here because it's already solved for y. So we just plug it in into that equation. So in place of x right here, we plug in the negative 5 over 11. So we now have 1 minus 3 times negative 5 over 11. And the negative 3 times negative 5 over 11 would give you a positive 15 over 11. When you add that with the 1, okay, 1, it would be the same thing as 11 over 11. So we add these together. 11 plus 15 gives you 26 over 11, which could give you a mixed number of 2 and 4 11ths. So the 1 point would be at negative 5 11ths, and then 2 and 4 11ths for y. And then you have the second point here where x is equal to 1. So this one is much quicker. So to solve for y, just plug back in. So you have 1 minus 3 times 1, and that's going to give you 1 minus 3, which is negative 2. So when x is 1, y is negative 2, which is that point right there. And we could double check by graphing both of these, both those equations. And when you graph, notice that we get this right here, where it intersects at 1, negative 2, and then this point up here, which is the decimal equivalent of these two fractions we got. So we have seen one example with unlike terms. Let's take a look at one more example with unlike terms, and this one's a little bit different than this first one. So the second example here, we have 2x squared minus y squared equals 2, and then x times y equals 12. All right, so it's a little different because the second equation, there's no plus or minus sign. It's just x times y. All right, so still we can solve for one of the variables because, all right, we don't have like terms. We don't have squareds for the second equation. So our first equation will stay the same, but the second equation we can solve for either x or y. In this case, doesn't really matter, but we can try to solve for x for this example. So to solve for x, we have to divide both sides by y. So when you do that, we now have x equals 12 over y. All right, so we've solved for x. So from here, we can substitute back into the first equation. So the first equation right here, this one, okay, in place of x, we're plugging in a 12 over y. So instead of 2 times x squared, we have 2 times 12 over y squared. And then the minus y squared equals 2 after that. All right, so from here, once we have substituted, now we can solve that equation. All right, so you take that equation, and we can square the 12 and the y to get 144 over y squared. And then we can get rid of the y squared in the denominator. To do that, we can multiply every term, every part of the equation by y squared. All right, so when you do that, I guess we'll do two things at once for this first term. 2 times 144 is 288. And then once you multiply 288 over y squared times y squared, okay, that's going to cancel. You're left with 288. And then the minus y squared, you want to multiply that by y squared. So y squared times y squared is y to the 4th power. And then you multiply the 2 over here by y squared to get 2y squared. So we just multiplied every term by y squared. All right, and now that effectively got rid of the fraction over here. And now we can try to solve. So we want to get everything together on one side. And let's make this y to the 4th power positive. So let's bring it over here. And so we can add y to the 4th to both sides. That would cancel over here. and then you can subtract 288 from both sides to bring the 288 over here. So what we have now is y to the fourth, and then plus the 2y squared minus the 288 equals, and then there's 0 on the other side. So what we have is an equation that we can solve. All right, it's a quadratic equation, or actually not quadratic, but it's a quadratic in form. We can think of it as a quadratic expression because we can factor. All right, so we can factor the same way we would if it was y squared, where to get the y to the fourth power, we can do y squared times y squared to get y to the fourth. Then we want something here and here that would multiply to get negative 288, and that would add to give you a positive 2. Now, when doing this, you kind of have to think through of factors of 288. Okay, so you can do 2 times 144, which those are too big of numbers, or the 144 is too big. You could do 4 times, and then 72 would work. You could do 8 times 36. You could do 16 times 18. And that's the one we actually want right here. And by the way, when doing that, it's just kind of mental math. So these numbers on this column, I just multiplied by 2, and then over here I divided by 2. So that's kind of my mental thought process, right? So that's why, if you notice the pattern, left side is times 2, right side is divide by 2. And notice right here, 16 times 18. If you make the 18 positive and the 16 negative, that would multiply to get negative 288 and would add to give you a positive 2 for the middle term. So we now have those two expressions. So we have those multiplied together equaling 0. So we can set y squared plus 18 equal to 0 and y squared minus 16 equal to 0. So we can solve both of these for y. So the first one, we just subtract 18 to get y squared equals negative 18. Second one, just add 16 to both sides. We get y squared equals positive 16. And then we take the square root of both sides of both equations. And when you do that for this first equation, notice we're going to have a square root of a negative number, which is imaginary. So that is not going to give us any answers that we need. But over here, y squared equals 16. If we take the square root of both sides, we now have y equals a plus or minus square root of 16, which would be 4. So we have two different answers, one where y is equal to positive 4, one where y is equal to negative 4. So now we have to solve for x for both of those, and we can use this equation right here because it's already solved for x for us. So x equals 12 divided by y, so we just take 12 divided by the 4 to get 3. So x is 3 when y is 4, and that gives us our first order pair. And then for y equals negative 4, that second answer, plug in negative 4 for y, we have x equals 12 over negative 4, which would be negative 3. So that second order pair would be negative 3, comma, and that should be a negative 4 right here. So negative 3, negative 4. And then if you graph this, we would find that we do indeed have the intersections at 3, 4, which is right here, this point, and then negative 3, negative 4, which is down here. So we've seen two different examples with unlike terms. And let's take a look at one example where you have like terms. So here we have x squared minus y squared equals 12, and x squared plus 2y squared equals 24. The first equation would be an ellipse, or a hyperbola, sorry, and the second equation would be an ellipse. So to find the intersection, this one, because they have like terms, meaning this column they both have x squareds, in this column they both have y squareds, we can use our linear combination method, which is the method we use when you had a system of linear equations. All right, so meaning we can multiply at one or both equations by a number, and we can also add or subtract the equations together. So our end goal is we want to be able to add or subtract the equation such that one of the variables would cancel. So when you do this, there's not one correct way to go about solving, but we're going to show you just one way where we can multiply the first equation by a number. So if we're looking to try to get the y's to cancel, you'd want to get the coefficients the same, or at least opposites of each other. So down here we have a positive 2. All right, so we have a 2 down here. We want to get a 2 of some sort up here as well. So if you multiply that first equation by a 2, we will now have 2x squared minus 2y squared equals 24. And the second equation would stay the same. So if we're trying to get the y's to cancel, we now can cancel by adding the equations together. So we see that right here. When you add them, okay, the 2y squareds would cancel out. And then we have 2x squared plus 1x squared. We get 3x squared. And then 24 plus 24 gives you 48. All right, and then from here we can solve for x by dividing both sides by 3. That gives you x squared equals 16. And then take the square root of both sides. So x would equal a positive or negative 4. So we have two different answers. One where x is positive 4. One where x is equal to negative 4. So to solve for y, you can plug the 4 back into either equation. We're going to choose the first one because the first one does not have coefficients with the x or the y terms. So if you plug a 4 in for x right here, we have 4 squared minus y squared equals 12. So we get 16 minus y squared equals 12. And then we can subtract 16 from both sides to bring that over here. We now have negative y squared equals negative 4. So positive y squared would equal positive 4. So y would equal a positive or negative 2. So when x is 4, y could be a positive 2 or negative 2. So we have two ordered pairs. We have 4, 2 or 4, negative 2. And then we do the same thing for x equals negative 4, right? Because we have two different answers for x, positive or negative 4. So if x is negative 4, we can find y by plugging again back in for x. So if you plug back into that same equation, we get negative 4 squared minus y squared equals 12. Negative 4 squared would be 16. And notice everything is the same from here on out. So we can solve to get y equals a plus or minus 2, just like the other one. So now, with x is negative 4, y would be positive 2 or negative 2. So we have two ordered pairs here as well. So we have negative 4, 2, and negative 4, negative 2. So we have 4 intersection points. So 4 different answers right here. And we can verify this with the graph. So when you graph this, we have an ellipse and a hyperbola, and they intersect here in 4 different locations. So depending on the equations we have, you would want to use either substitution method or this method here called the linear combination method. And that concludes our lesson for today. We will see you next time.